Now that we know what a log is, we're going to go back and look at how we actually evaluate logs and get answers. So there's two types. You basically have the ones that the calculator is going to be your primary source, and then the ones that you don't really need the calculator to do much other than check your answers. So we're going to start with calculator. I've already mentioned where the buttons are, but I want to just kind of show you them in action. So if you are asked to evaluate a common log, you'll just see the letters LOG. The base won't be written there because it's understood to be 10. Any common log you can do on your calculator by just hitting the button that says LOG. So you hit the button that says LOG, you type in whatever number they're asking you to take the log of, and you get your answer. So your common log button, again, it's in the first column, about halfway down. So if I want to do the log of 0.01, I get -2. The other one that's on your calculator is the natural log button, and it's the one that says ln on your calculator. So if you want to take the natural log of 27, you're going to find the button that says ln on your calculator. It's right below the one that has just log, and you're going to type in the number that you're asked to take the natural log of, and you're going to get a lot of decimals. I'm going to go 2 places, so this is about 3.30. And then to find the natural log of 342, same thing. We're going to hit the ln button, the natural log, 342. You do get a lot of decimals with natural log. You get about 5.83. So those are ones that those two calculator buttons will help you. If it's not a common log or a natural log and it has a different base, the base will be shown. These are ones, and I'm only going to ask you ones that you could figure out without using a calculator. Although the calculator is a nice way to kind of check your understanding. So when you're doing this one, what you're saying is 2 to what power equals 8? That's what you're trying to figure out. What power do I have to take 2 to get 8? So you might have to trial and error, just keep trying. Okay, what's 2 to the first, 2 to the second, 2 to the third, 2 to the fourth? You end up getting 3 because 2 to the third power is 8. For the next one on the right, what you're saying is 4 to what power equals 16? And hopefully that one's a pretty easy one for you. 4 to the second power is 16. The next one, you have this base 5, so you're saying 5 to what power equals 125? Here's where I mean the calculator can help you kind of guess and check. This one is 5 to the third power, so my answer is 3. My answer is just the exponent. Next one, we actually have a property that says no matter what base, if we're taking the log of 1, we always get 0, because any number to the 0 power is going to equal 1. Here's some more. These are pretty quick, but I just want to kind of show you a variety. So the next one is 3 to what power equals 81? This might take some trial and error as well. 3 to the first, the second, the third. It ends up being 3 to the fourth, so your answer is 4. Next one, 8 to what power equals 64? So 8 to what power equals 64? You end up getting 2, the second power. Now when your numbers start getting smaller, so we're saying 9 to what power equals 3? And the idea is, what am I going to do to make something smaller? Well, if I'm making something smaller, I'm either doing a root, like a square root or a cube root or a fourth root, or I'm doing a negative exponent. So those are the things you have to think of. So to go from a 9 to a 3, we are square rooting it. Now keep in mind, square rooting is the 1/2 power. If we were cube rooting it, it would be the 1/3 power. So since this one is a square root, my answer is a half. For the next one, we want to figure out 8 to what power equals 2. Again, it got smaller, so you're thinking, okay, did I take a root? Well, the square root of 8 is not 2, but the cube root of 8 is 2, so that is the 1/3 power. For the next one, so now we have 5 to a power, and we end up with 1/25. So first thing you should notice is you end up with something with a denominator. So when you are working with a denominator, the exponent must be negative because the one negative exponent moves it to the bottom. So you're thinking, okay, what power did I take it to get it to be 25? Well, that would be the second power. But because that 25 is in the denominator, your answer is actually the -2 power. So 5 to the -2 power is the same as saying 1/5 squared, which is 1/25. Same idea with the next one. 4 to what power equals 1/64? Well, it moved it to the bottom, so it must be a negative power. And to go from 4 to 64, we cube it, so that would be a -3rd power. Now, the next one is a common log, so you could do this one on your calculator, although it is not a bad one to do in your head. So this is saying 10, because that's a common log base, to what power equals 100? Well, to go from 10 to 100, we get the second power. And then finally, 6 to what power gives me 1/6. This moved to the bottom, and then it didn't do anything. So it's just the -1st power because it kept it a 6. but it did move it to the bottom. So that's how we go through and evaluate logs that you can do with little to no calculator help of going through and evaluating what I would consider basic logarithms.